at the simplest, in the biggest, broadest picture, the Earth's processes take place in Wilson cycles. And the Wilson cycle, imagine these are a continent. A Wilson cycle is the rifting of a continent, the opening up of an ocean basin between them, and then the closing of those continents, the subduction of that ocean, and a collision. So this rock, the coarse-grained one, the granite, was produced during the closing phase of one of those Wilson cycles. The ocean floor was dipping underneath, actually dipping underneath the edge of Virginia. Magma was coming up from below and intruded and then solidified slowly to produce this one. That created a supercontinent, Rodinia. And at that time, South America was right off the east coast, so you could have walked from Virginia to South America without getting your feet wet. They were just slammed together. But that supercontinent then began to rift apart, and that was the opening phase of the next Wilson cycle. And as it pulls apart, magma comes up from below and spills out onto the surface to form lava flows. And so this is the opening phase of a Wilson cycle of an ocean basin. This is the closing phase of a Wilson cycle or an ocean basin.
So in a billion years, would the lava in Hawaii become potentially this?
Yes, it could. It's going to have to be buried and put under some heat and pressure, but yes, it could.
Yeah.
And so what Lynn...
Iceland as well. The lavas and the volcanoes in Iceland as well, which is an active rift area right now. It's actually separating apart. You can walk down the rift valley itself right there and have the same type of lava, basalt on either side of you. If that's preserved and metamorphosed, it would end up looking like creation.
And so what Eric has got in his storyboard there is what Lynn was talking about, the Wilson cycles. And so if you, basically to understand the trail, you read the text up above, and that kind of gives you the big picture. And somebody said earlier, if that's all they get out of this, that's good. But then you have to go through the, yes, excuse me.
I just have a question.
Oh, you have to keep going through, and you see you start at the bottom. Don't ask me why it's a geology thing. You start at the bottom and you read up. You see 8's up there and 1's down here. You got to remember that. And so that will, you know, in billions of years over here. So you're going to have to play with it a bit to understand it. But I will tell you, while they're holding this, we were out here and Chip was challenging these gentlemen. How wide is the Rockfish Valley Fault? Does it go from that hill to Black Rock? Or is it this wide? Where is it? And their answer is, we must see evidence on the face to be responsive to that question. And Chip knew that he wanted somehow for everybody to say, it goes all the way from over there to west of the river. But we had not found any evidence. And one day we were here, the four of us, and we walked up the river, and we went where you will go, and we walked across the river, and all of a sudden Lynn said, let's look closer. And now this map, this one, got changed because this unconformity here was discovered on the ground by a field geologist looking, but before he wouldn't put that line on there, and Chip was determined to have that line on there. and we
I tried to tell him to put the line there.
and so there's more to be discovered, right? Yeah. So we just got to find the outcrops, and we just got to keep discovering it. What we do know, and this fascinates me because if David McGann puts down a well 150 feet, in this valley, you're going to get close to 20 gallons of water a minute. And if you can think about those hills over there being 14,000 feet and then not even 2,000, that one might be. And you can think of these being 14.
Which is taller than the Himalayas today.
And,
right?
and Three Ridge is just, you know, that's
But-
under 4,000. So go to 14,000. And then they look like this. You got that one that's coming down this way, and that one's coming down this, and they look like this, and they have joined together, and so all these gravels start weathering away, and they start filling that up. We don't know how deep the gravels are under here, but any well driller will tell you when you start drilling a well, if you find bedrock, solid bedrock at 85 feet, that's quite unusual. You can go down 165 feet and you're still digging in gravels, and they don't really like to do it because it messes up their drill bits. But there are a lot of limestone. Have we got any limestone in these rocks? So we don't have a limestone rock here, but there's a lot of limestone that was in these rocks that came down, filled that up, and that's why we've got the sweet water sitting down there. I mean, that's my oversimplified, I go to sleep thinking, I sleep well because that's how I decided it works. But that's why I don't teach geology.
You think I'm going to challenge that?
So that was a question, and it wasn't for me. Let's ask these guys.
What's happening on the East Coast presently? Are we in one of these Wilson cycles, or are things static? Or
We are in the opening phase of a Wilson cycle. Prior to this, Africa and Eastern North America were joined. About 270, they began to separate. The Atlantic Ocean has been opening ever since. Right now, there is no evidence that that ocean basin is ready to close, but it's getting to be an old ocean basin. And what happens is, as the ocean rocks cool, they become denser and they want to sink. And at some point, they'll break free and they'll start to descend down into the interior of the earth. And that'll start a closing process. So all this geology here, which was the result, is going to happen in the future. It will. We don't know when, but it'll do it again. Yes, sir.
you talked about a Rockfish Valley fault. Does that mean, is that a kind of fault that's going to cause an earthquake?
Probably not. The faults that the Rockfish Valley is a part of happened when Africa collided and slid over the eastern part of North America, and it took all of the rocks that were here and broke them up and shuffled them like a deck of cards. And the Rockfish Valley is partly the result of that, but apparently it has moved more than once. So it's got a long, complicated history. I don't know if I've answered your question.
But these are not plates or whatever.
Yeah, these are not plates. This is just
a break.
Well, yeah, a break where we're pushing it and the rock cracks somewhere in the middle and one starts to slide past the other.
Yeah, the forces that created those faults aren't here today. The compressive force that was squeezing everything together, shoving everything up, ramping it upwards here. Those forces aren't here anymore. So would you see the same kind of motion on the fault today that caused it in the first place? Probably not. But what you will get is all sorts of little adjustments along the way. As material is weathered away, it actually is going to lift up just a little bit, and with any movement this way, it's going to cause it to want to compensate in other ways. But, you know, big earthquake,
So our earthquake that we had a little bit ago could have been a readjustment on one of those old faults.
exactly, exactly.
That is one of the ideas, is that as the ocean basin is open, it's pushing against the east coast, and that fault was just an adjustment to it. That's why you would get a reverse.
That's why you'd get a
exactly.
reverse fault, yeah.